Warning: Cobalt nitrate and manganese nitrate are toxic and cobalt is carcinogenic. Gloves, masks, and other chemical protective gear should be worn. This experiment should be performed outside or in a fume hood. Greetings, fellow nerds. Various electrochemical reactions require anodes that do not degrade when used. Carbon is cheap but degrades easily, and platinum is extremely expensive. In a previous video, we showed titanium could be used as a cathode, but not as an anode due to an effect called passivation. We still want to take advantage of its mechanical strength and chemical inertness, so to use it as an electrode, we need to coat it with a conductive material that's still chemically resistant. In this video, we're going to coat titanium with cobalt and manganese dioxides to turn it into viable anodes for various electrochemical reactions. First, we need to activate the titanium. This is because titanium reacts with air to form a thin but somewhat insulating oxide layer that we need to get rid of. First, get your titanium and sand it with some coarse sandpaper. It's actually not recommended to use a fine grit because we actually want the surface to be a little rough so that the cobalt and manganese oxides can adhere better. Now once the titanium is thoroughly sanded, we immerse it into boiling hot concentrated hydrochloric acid. Needless to say, this should be done outside or in a fume hood. This etches the surface and dissolves any remaining titanium oxide. Once the titanium oxides are dissolved, the titanium metal should start fizzing as the bare titanium is reacting with the acid to produce hydrogen and titanium trichloride. As this happens, the solution will gradually turn this violet color. When you see this color, the titanium surface is activated and we're ready to start putting those oxides on. And we'll need a beaker of cold water, and we'll need a saturated solution of cobalt nitrate, which we made in a previous video. Let me take the titanium off boiling. We need to decompose the nitrate onto the titanium in order to generate the oxides. Since this process is rather messy, I'm going to protect my hot plate with some aluminum foil. Here is our activated titanium surface etched by the acid. Give it a quick rinse in water to get off the acid. Now place onto it a thin layer of cobalt nitrate solution. Drip off any excess. Now place it onto the hot plate and hold it down with a glass rod for better thermal contact. As the titanium heats up, the cobalt nitrate will decompose into cobalt oxide. My plate is heated to its maximum temperature of 300 Celsius. It's hard to see, but there is brown nitrogen dioxide gas coming off the electrode as it decomposes. Anyway, once the nitrogen dioxide is gone, the decomposition is done. Dip the electrode in cold water to cool it, and also to use the steam bubbling to blast off any loose cobalt oxides. Then wipe it down to remove anything that isn't strongly adhered to the surface. Towel it off and then apply another layer of cobalt nitrate and bake it again. Keep repeating the whole process as many times as you like, and remember to do both sides. I used about 4 layers or so. As a side note, the steaming, wiping, and washing steps are optional. I've been told that other experimenters have avoided them without much ill effects. You might ask why we can't simply paint it on, and it's because baking it on gives better electrical contact and stronger adhesion than painting. Now we have a cobalt on titanium electrode. Here I'm using it to electrolyze a dilute solution of 5% sulfuric acid, and as you can see, it doesn't passivate like pure titanium. The cobalt oxide on the surface is electrically conductive and serves to transfer electrons from the titanium to the solution without creating an insulating titanium oxide layer. Now this would be great if cobalt oxide lasted forever, but unfortunately the cobalt oxide is slowly decaying. Eventually this will passivate once the cobalt is gone. To make it last longer, we place an overcoat of manganese dioxide, turning it into a manganese dioxide electrode. To do this, we go back to the hot plate and start applying layers of manganese nitrate. Normally it's pink, but mine is contaminated with iron. This doesn't adversely affect the electrode, however. Using the same techniques as cobalt, we decompose the manganese nitrate onto the surface to make manganese dioxide. You can apply as many layers as you like. The more layers you have, the longer the electrode will last. I'm going with about 5, but I've heard of other people going to 20 or even 50 layers. Now you might be thinking, why don't we apply the manganese nitrate to the titanium directly and skip the cobalt layer? This is because the manganese dioxide is highly oxidizing and will actually directly oxidize the titanium, forming a passivation layer of titanium dioxide between the manganese dioxide and titanium. Having cobalt in between the two layers avoids this. And here we have our manganese dioxide electrode. Here, once again, we are passing a current through dilute 5% sulfuric acid solution. Now, while this will last longer than a cobalt electrode, it suffers from some problems with flaking, as well as this production of purple permanganate. So if you intend to use this electrode to make chlorates, you'll need to deal with this contamination, usually through filtration and recrystallization. For those of you only intending to make oxygen and hydrogen by electrolysis, this isn't a problem. A further treatment you can do is to apply a layer of electrolytic manganese dioxide. In this case, get about 90 grams of manganese sulfate that we made in a previous video and dissolve it in 500 milliliters of water. Add another 12 milliliters of concentrated sulfuric acid and heat the solution to 90 degrees Celsius. This will take a while, so I'll just skip over that part. Now we're going to electrodeposit manganese dioxide onto it. I'm using a titanium cathode, but you can use a copper cathode as well. Now, making the manganese dioxide electrode as the anode, run through a current of up to 10 milliamps per square centimeter. In this case, I've got a two-sided electrode of 50 square centimeters each, so that's 1 amp in total. As it runs, manganese dioxide is deposited onto the electrode. The manganese 2 ions are oxidized to manganese 3, which in turn disproportionates into manganese dioxide. I ran this for about 5 minutes. And now we have a deposit of hard manganese dioxide. This treat electrode has less problems of permanganate production, but unfortunately still seems to flake. If I electroplate for longer, it seems to lose adhesion and flake even more. I'm still working on this problem, and hopefully I'll make a better electrolytic manganese dioxide electrode in the future. Now alongside this, I'm also working on a lead dioxide electrode starting from this ingot. A lead dioxide electrode is even better and can also be used to make perchlorates, unlike manganese dioxide. But due to the toxicity, I first got to figure out how to do this safely. So thanks for watching. Please subscribe, rate, and comment.